Okay, welcome to BESS. I'm going to kick us off now. I think Stefan should be joining us shortly, but I'm going to start now. We have a very full agenda for our slot. So here is the note well. I'll just leave that on screen for a couple of seconds. Okay, for the note-taking, there's actually a link in MeetEcho to a new tool for note-taking, but you can use Etherpad as well. But we have Mankamana also, who's our secretary, who's going to be taking notes during the session. So thanks to Mankamana. Here is the agenda. The only thing I'd like to note on the agenda is that BGP multicast SR draft from Jeffrey is actually going to be discussed as part of the discussion of the multicast controller draft. Please stick to your slots. As I said, we have a very tight agenda, and MeetEcho has a habit of just kicking us after the meeting 5 minutes after the time, without very much warning. So onto the status update. We have no new RFCs since the last IETF. We have two in the RFC editor's queue. The overlay draft, EVPN overlay DCI draft, and EVPN prefix advertisement. We have quite a few drafts with Martin and in IESG review at the moment. There are a couple of questions, I think, for Ali to address for the inter-subnet forwarding draft. NA flags, optimized IR, and the proxy ARP neighbor discovery draft are all in IESG review. The BGP control plane for NSH is in IESG review. The really old VPLS multi-homing draft that's been working for a very long time is with Martin at the moment. So there was one IPR hiccup that had to be addressed. I think that's been addressed now. I did post, there was a late IPR declaration on that, so I did post something to list on that, but we didn't see any comments. The bond procedure updates is with the ISG, as is the RFC 5549 revision. And we have just sent the publication request for in the last few weeks for the EVPN OEM framework. So that's hopefully with Martin now. Quite a few documents in Shepard's review as well. So the IRB multicast document, Mankamana is reviewing this at the moment. He expects to finish it in the next few weeks. I should post a Shepard's review, and once that's addressed, hopefully we can publication request it. The EVPN unequal load balancing draft, Stefan's review is done for that, so expect that soon. The virtual Ethernet segment document is awaiting a write-up. Write-up's completed for the MVPN MSDPSA interoperation draft. EVPN preference default forwarder. Stefan is following that up at the moment. And Mankamana is currently updating the IGMP MLDP proxy document, which he expects to have done in the first week of August. So we have some ongoing polls. So the ones of note are the SD-WAN usage draft is missing one IPR response before moving forward. Just as a reminder, all authors and contributors need to reply to the IPR. Yes, I can hear you, Linda. You're very quiet.
I think we have all the authors responded with IPRs for the HPSD1 usage.
Hello, can you hear me?
Yep.
Stefan speaking. Yeah. No, I think at least on my side, I'm missing the reply from Basil from Bell Canada.
Oh, he did.
I haven't seen his reply, whatever on the mailing list or in my mailbox.
Oh, maybe he's. Oh, I can look for his reply. I remember I saw his reply. Okay, I'll look for that.
Okay. The EVPN LSP ping draft was in working group last call. There's a few comments on that and also a comment from one of the MPLS working group chairs. If the authors could please address those comments before we move that forward, that would be appreciated. And the EVPN Geneve draft, there's a few comments on the list as well that need to be addressed by the author before moving forward. Here's the list of the ones that we have in our queue for as being ready for working group last call. The aggregation, EVPN aggregation label document, IVPN interworking, and IRB extended mobility. Now some status on some of the working group documents. The multicast flow DF election, Mankamana's updating this since IGMP proxy draft has now advanced. There's no update to the fast DF recovery. No updates to a few of the drafts listed on this slide as well. There are some questions to the authors for the MVPN Yang draft. We haven't received a response from them yet. Stefan, I don't know if you want to say anything about the Yang drafts.
No, I think the status is exactly the same as we had from the last interim meeting. There is no particular change.
Okay, one new working group document, which was draft GM SM BESS EVPN BFD. Okay, we also have a list of documents that we're going to poll, we believe are ready for working group adoption, and we're going to poll shortly in this order. The EVPN L2 gateway protocol, EVPN multi-domain split horizon, and the Yang model for VPN service PM. Okay, and that's it for this status update. So I believe first on the agenda is the SRv6 services draft. And Gaurav is presenting. I think you have to go.
Yeah.
Yeah, okay.
Can you hear me?
Yes, we can hear you.
Hi, everyone. Good morning, afternoon, depending where you are. So this is the SRv6 based BGP services draft. Next slide, please. So this draft specifically covers the extensions for L3 VPN for v4 v6, EVPN, and also for the global v4 and v6 services. Next slide. In terms of the progress of the document, we presented it first in IETF 98 Chicago. We have later introduced the EVPN and global services at 101 IETF and presented at IDR. We then moved to draft to BESS and presented in 104, also added the update optimization based on the input from BESS members. The document was adopted in IETF106, and since then we have done multiple updates to the document based on the various comments and addressed most of the comments on the mailing list. Next. We since the last IETF, we have updated some field encoding based on these are some minor changes. So setting of the unused flag, and also how do we handle some unknown behaviors. Also, there was a slight update to the security consideration section. Next slide, please. INI allocation has been made for the SID TLV type, the L3 service TLV, and also for the L2 services TLV. And these are used in the field deployed implementations in various customers. Next slide, please. Now, in terms of implementation and also from the deployment, it's widely deployed. It's widely implemented. We have shipping versions and pretty stable versions coming out from 2 vendors, Cisco, Huawei, and other vendors. We also have open source implementations of the protocol in XRBGP and the Go version of the BGP, and also being leveraged in the data planes, Linux, and FDIO. In terms of the deployment, it's deployed in multiple customers at SoftBank, China Telecom, Iliad, Line Corp, China Unicon, MTN Uganda. The full implementation list can be found in the document below, but it's widely deployed and used in the field. And also the multi-vendor interop was presented at EANTC since 2018. Next. We as an authors, we believe the draft is in pretty mature state now, with multiple existing implementations from various vendors, and also the deployment list, as some of the I mentioned with the customers. So we would like to request the last call for this document. That's it. Thank you.
Okay, thank you. Any comments? Okay, if you would like to make a comment and you want to be in the queue, can you raise a little button at the top to add yourself to the queue? Guyan, I don't know if you're deliberately in the queue or not. I can see you in the queue. Okay. So,
I think I just hit the button, but I'm okay.
Okay. Sherman, I can see you.
Hello, can you hear me?
Yeah, go ahead.
Okay. Zhen Bian from Huawei. Since this the SRv6 VPN are very important and have multiple deployments, so we think that the draft has also well written. So I think I'm not sure how can we show we want the request for the working group last call. So is it okay in this meeting or in mailing list?
Yes, if you believe this is mature, then certainly you can make the request in this meeting, and we can look at adding it onto our list.
Okay.
As it states on the slide. So, okay. Okay, Sue, I think you're next to me.
Hi, can you hear me?
Yes.
Okay, good. Question for authors. Do I have other drafts in IDR that need to be also last called at the same time? I'm doing some. Do I have all the right ones? Thank you.
So actually this brings a good point. So we've had a few issues in BESS recently where we've got kind of gating references between drafts. So if authors could please make sure that all of their references are in line, ideally, well, that would be the ideal case before you request working group last call. Obviously, it's part of our job as shepherds as well to check that is in place.
Yeah, if I remember correctly, for this
We'll
draft,
check
we have a dependency on the EVPN FXC1. It is a normative reference, if I'm not mistaken.
Okay. Ketan, I think you're next in line.
Stefan, that reference was a leftover in error, so I think Dot should remove that. And to answer Sue's question, this document doesn't have any dependencies on any document in IDR. They are, unrelated. Of course, this does have a dependency on the SRv6 network programming, which is in Spring currently in AD evaluation. But I think all others have been worked out. Yeah.
So if you can try to fix the FXC dependency before we can move forward, that would be great.
Yes, I will request the authors to do that. Yeah, thank you.
Yes, we can do that. We'll remove that. There's no dependency on FXC.
Okay. All right. Any other comments before we move on?
I've got one if I'm on.
You're on.
Okay. The question was not whether there were dependencies. I assumed you'd get dependencies. If you had other things that enabled the deployments that we should push along in IDR that were not, just let me know. That was the real request. Thanks.
Back to you on that.
Okay, thank you. So next up is Neeraj.
I will drop off in that case if this is done.
Okay.
All right.
Thank you. Neeraj, are you there? Do not see you on the list. Of participants. Okay, it's unfortunate, but that saves us some time. Okay, well, maybe we'll park that one for now. Jeffrey, are you there? Jeffrey, are you there? You're up next. I can see you on the participant list. There we go, hopefully.
Okay, can you hear me now?
Yep.
Okay, so I want to provide an update on the two drafts. One is BGP multicast, another one is BGP multicast controller. Next slide, please. So the BGP multicast draft is about using BGP to do hub-by-hub signaling, basically as a replacement for PIM and MLDP. So there are basically two major changes. Well, it's not that major either. The first one is we added a route distinguisher to the NRRI. That way we can do signaling in the VRFs. This is mainly to support signaling from controllers. But since the NRRI is defined in this document, so we updated this document for about the RD. The next one is the inter-region support. Here, the region could be an area or could be a AS. There are three subtopics about this. One is that's BGP signaling through a region. especially when you are using the BGP-LU, such that the internal routers in a region do not have the routes towards the source or towards the tunnel route. In that case, how does the internal routers do the RPF check towards the root of the source? This is a solved problem for PIM and MLDP using PIM RPF vector or MLD recursive FAC. The same idea will be applied to here. We basically add RPF extended community to specify the upstream border router to which you should be doing the RPF against. And next one is the overlay signaling through overrun region. This is very much like the MLDP over targeted session, where you have a region that you do not run on BGP signaling towards the to the internal routers, but you just do the BGP signaling over that region to the border routers. But when it comes to how to get through that region, then you can use either P2P tunnel from border router towards the border router, or you can do P2MP tunnel inside that region, and you stack the traffic on top of that P2MP tunnel. Again, this is just like MLDP over targeted session. Finally, interworking with controllers, signal broadcast. So in the inter-region scenario, it could be that it spans multiple regions and where you have a hub-by-hub signaling in one region, and you have controller signaling in another region, and yet you have another controller for a different region. So how the interworking is done together. So that's next slide. And then for the controller signal BGP multicast drafts, there's three changes in this. One is that tunnel encapsulation attribute enhancements. The other one is also multi-domain support, and we also added SR P2MP support. Next slide, please. So tunnel enhancement, encapsulation attribute enhancements. So when we talk about the multicast forwarding, there is this, with the forwarding state will include upstream information and downstream information. So now the upstream information is actually included in the tunnel encapsulation attribute itself. So before, well, each tunnel listed in the tunnel encapsulation attribute represent a replication branch to a downstream neighbor. Now, even the upstream info is represented as a tunnel in that TEA, tunnel encapsulation attributes. That is indicated by a new sub TLV we call it RPF sub TLV. If you have that, that means that this is actually for upstream information. The next change is the incoming label stack. This is what this was introduced for MP to MP support. You have, for example, when you have a multi-point to multi-point MLDP, and then for each neighbor, whether it's upstream neighbor or downstream neighbor, you may send traffic to it, and you may also receiving traffic from it. And so currently the label stack TLV, sub TLV in for MPLS tunnel is for outgoing traffic, and for incoming traffic we added this new incoming label stack sub TLV. It's the same as the existing label stack sub TLV, except that it's a new type. So for MP to MP, a tunnel will have both the incoming label stack and the regular label stack, and then even for P2MP case, for the upstream tunnel, then it will have an incoming label stack instead of a regular label stack. But then for the other downstream tunnels, then for P2MP, then you will only have the regular label stack for outgoing traffic. Next, please. So multi-domain support, you consider the situations where you have multicast tree or tunnel spans multiple domains, multiple regions, where different domains have different controllers. I realized that in the earlier when we talked about BGP multicast draft, I was using the term region, and here in the controller draft I switched to domain, and that's a mistake on my side. Here, when you see domain or region, it is the same. I will update this, the drafts to be consistent. So here you have controller 1 for the region on the left, and controller 2 for the region on the right. Now the router A and B in the in region 1 or domain 1, router C and D in the other region. Now notice that the controllers only control the routers in its own region. And now for native IP multicast, it's simple. It only controller 1 only needs to say that router B needs to replicate to this downstream interface. And the controller 2 will only need to tell router C that your upstream interface is this one. And then things will work. But when it comes to labeled multicast, then the router C and B will need to know what labels to use on that link. Now, there are two ways to do this. One is that somehow the controller 1 and controller 2, they coordinate so that they know that's what label to use on that inter-region, inter-domain link. The other one is that they don't coordinate, but you do the hop-by-hop signaling between the router C and router B. So router C tells router B that, hey, I'm joining your tree, and here is my label to use, things like that. So that the next situation is that there is a border router B that sits on both domains, and now the controller 1 and controller 2 both talk to router B. We had said before that when the router B receives the LibAD routes from both controllers, the BGP route selection procedure will pick one of them, and that is used to set up the forwarding state. And now the router B actually needs the information from controller 1 to set up the upstream information, and needs the route from controller 2 to set up downstream information. So in this case, router B is provisioned as a border router, so that it can it knows that it needs to look for routes from both domains to set up a forwarding state. Next slide, please. Okay, SR-P2MP support. SR-P2MP has been accepted by the Spring and PIM working groups. In the Spring working group, it's about replication segments, which is a building block. It represents the state on individual nodes of a tree. And in the PIM working group, they have this SR-P2MP policy to set up P2MP trees. Notice that MPLS SR-P2MP tree is not different from MLDB tunnel in the forwarding plane. The difference is in the control plane. The tree is calculated by the controller and then signaled to the routers on the tree. Now, their signaling could be done by netconf, by PSAT, or by BGP. And in case of BGP, there are actually two flavors. One is BGP SRT based, and the other one is BGP MCAS based. BGP MCAS is basically this our draft here, BGP broadcast controller. As people say, those are just different ways to skin a cat, and here the cat is the SR-P2MP tree. And now notice that with BGP MCAS, all we need is a new NRI type to do the SR-P2MP. So this is the same way, existing way to skin a different cat. A different cat here means the SR-P2MP instead of IP multicast tree or MLDP tunnel. Next slide, please. So the replication segments is identified by root ID, tree ID, and node ID. The node ID is basically says which node this replication segment is for. You can see that in this NRI, I have 3 red fields. That's basically how it's identified. We have this new route type, and with those information in there. And with that, there is nothing new needed to signal SR P2MP in case of SR MPLS. However, optionally, you can use a SR policy tunnel in your tunnel encapsulation attributes. And when you do that, optionally, then it becomes explicitly tied to the SR. Next slide, please. So what is our SR policy tunnel? Originally, it's defined to instantiate the SR P2P policy. Now here, the SR policy tunnel is a tunnel type in the tunnel encapsulation attributes. So that tunnel specifies the binding state and outgoing seed list for the SR P2P policy, among other things. But when we use the SR policy in the tunnel encapsulation attribute for SR P2MP, it basically refers to a pre-installed SR P2P policy as a replication branch. It basically says you have a downstream node and you can use the SR P2P policy to reach it. Now, how does it work? In that SR policy tunnel, you specify binding seed, and when the node gets it, the signaling, then it uses the binding seed to look up the pre-installed outgoing seed list. And that tunnel also has a seed list. It's just one seed list that basically specifies the outgoing seed for the tree. Now, you put this together, you have a seed list that you use to send the traffic to downstream. Next slide,
Jeffrey,
please.
you just have 1 minute left, so you have to conclude.
Yeah. Sure. Next slide, please. SRPWP policy is on the tree head, and that can be actually signaled using the replication segment itself. We just attach a new attribute, a BGP community container, to specify the information for the PFP policy, including the candidate path priority and set of leaves and policy names, things like that. Next, please. So summary, this draft for BGP multicast, which is hop by hop signaling or control signaling, it's getting more and more mature in both the draft work and proof of concept implementation. I do need to spell out more precise procedures, but it's just the exactly what you kind of route you originate, what things you do when you get receiver route. But other than that, it's pretty much there, the concept and how you implement it. So I will present to the IDR working group on the proposed TEA changes. But we do have more work to spell out the precise procedures. I'm done. Thank you.
Okay. So I think one brief comment from you, and then we need to move on.
Yes, I look forward to hearing the TE changes. I wondered if he had a 2-line sentence that can tell me what he's looking for there.
I'm sorry, can you say that again? The 2-line sentence for what?
On what TE changes you're going to make.
Oh, I talked about some TEA changes in this slide already, but in the IDR presentation, it's more systematic. I have sent the slides to the IDR, and then once they publish, you will see it. And then,
in respect to my best colleagues, I will pick up your questions on Friday.
Yeah. Okay. Thank you.
Thank you.
Thank you. All right. Next up is Shaba. Thank you, Jeff. There we go. Shaba, you should.
Can you hear me?
Yes.
Yeah. So, yes, I'm presenting this draft on behalf of the other authors. It is about MVPN and EVPN services over SR P2MP trees that Jeffrey just presented. Next slide. So what Jeffrey presented was how SR P2MP trees can be instantiated using, BGP MCAS SAFI. So what this draft covers is procedures for delivering MVPN and EVPN services over such SR P2MP trees. This draft was initially published last year. It only covered MVPN services, and we recently added EVPN too. So the current draft now covers both types of services. Next slide. So I think, as Jeffrey mentioned, we have basically SR P2MP consists of two building blocks. One is what we call as SR Replication Segment, which is the foundational construct for providing a P2MP replication in a SR segment. And then we have a SR P2MP policy, which builds on top of that and allows a PC to compute a tree and then instantiate a tree in SR domain by stitching these replication segments together. So these two are covered in the drafts that I mentioned over here in the spring and the PIM working groups. And recently, both of these drafts have been adopted by the respective working groups. Right? So in this draft, we basically specifying how MVPN and EVPN procedures are modified to support such services over the SR P2MP tree, right? So the basic approach is that a root of a P2MP service discovers the endpoints using the auto discovery routes, and then it communicates with the PC to create and update a SR P2MP policy with this endpoint set that is discovered. And then the PC can compute a SR P2MP tree and instantiate the tree in the SR domain using any southbound protocols like P7.conf or BGP. Right. So in this draft, the real standardization effort is just defining a new PIMZ tunnel attribute for SR P2MP tunnel. The tunnel identifier is tree identifier in the context of the root. And then the normal MEPN, EVPN auto discovery procedures apply to basically discover the endpoints of the service and communicate that to the PC. Right. Next slide. So at this moment, we are just seeking comments from the working group. This draft has, as I said, this draft has been published for well over a year now, and it is supported by different vendors. So we just want the working group to go, and provide comments on the draft. Any questions?
Yeah, thank you. Folks, please step up to the queue if you would like to make any comments. Okay, thank you. Next is Linda. Oh, wait a minute.
Can you hear me? Hello?
Hello, it's very quiet.
Oh, okay. I'll speak louder. Okay. So, how is this volume? Is it better?
A little quiet for me. I don't know if others can hear.
No, you are really far.
Okay, I'll talk louder. So this is the update for the BGP usage for SD-WAN. The main purpose of this draft is to tell the industry there are quite a few other organizations doing SD-WAN, and we want to show that BGP actually is very well equipped to do the control plan for the overlay network. Next page, please. Okay, so this is just helping people to understand the draft. Here are the main thing being discussed in the draft. We have requirements, we have 3 scenarios, and we use the BGP, the control plan. How do we walk through how the BGP control plan works for each of the scenarios? And then we describe the traffic flow, how the traffic goes from one side to another side for each of the scenarios. Hopefully that can help people to read through the draft. Next, please. So this one, we describe the key characteristics of the SD-WAN networks, mainly their augment of the transport. Instead of using VPN, this one can use different type of overlay and actually can aggregate traffic from multiple underlay networks. And another one we added to in this draft is application routing. Application-based routing can be based on application ID. It can also be based on specific performance of the network. Next page, please. For the SD-WAN segmentations, which is highly desired by many deployment, there are 2 aspects. One is the control plan to be able to be able to represent control messages by different instances or segments. Another one is the data plan. So the BGP itself already have embedded extended community, the route target, to be able to represent control messages belonging to different VPNs. And here, because the SD-WAN segmentations can consist of existing VPN and other IPsec VPNs. So we'll just be able to using a differentiated target ID to represent this is actually SD-WAN overlay target ID, all the instances. And then from data plane perspective, the data traffic themselves need to carry the SD-WAN ID. And for the VPN, existing VPN, there are already methods to carry the differentiators. And for the IPsec VPN, the virtual network ID can be carried by the encoding, whether it's GRE or VXLAN, which is inner encapsulation of the IPsec ESP tunnel. So both can be covered by the BGP, can be achieved by BGP. Next slide, please. Okay, so this is just to show that why BGP is used. BGP itself has the ability to constrain the distribution. One of the characteristics of SD-WAN is the edge nodes are very far apart from each other. And some of the nodes, when power up, don't even know who his authorized peers are. So they require using, like, for example, RFC 4684 to be able to constrain the distribution of the propagation. And there could be also policies being enforced so that only authorized peers can receive the update. Next page, please.
Adrian, did you want to make a comment?
I had a question, but it goes back a couple of slides, so I'll hold it till the end.
Okay.
Next slide, please. Okay, so here is through the draft itself showing how do we the BGP's message flow. So this just shows example of when a CPE or edge node has a bunch of client routes and being propagated through the RR to the authorized peers. So with this kind of method that can simplify the IPsec attribute distribution, because here in this picture, we assume that there is already a secure channel between the RR and the edge nodes. So that can ease the authorization of the message of the IKE v2. So this just shows how do we how do we propagate the routes to represent different paths. Next page, please. This one shows that for the SD1, they may have different topologies. Like, for example, here in this example, the VLAN 25 and the route 22./24 need to be only exchanged with CPE3 versus VLAN 15 only being communicated with CPE1. So with that, using two separate BGP messages with different target can achieve this purpose. Okay, next one, please. So this one to show that if the client prefer to have a client address-based encryption, per route-based encryption, and they can use different BGP messages to be able to indicate, like, for example, 10.1 using specific IPsec attributes. And VLAN 15 use another set of IPsec as a security association attributes. And then the last one being the 12.1 using another new set of IPsec security association attributes. With this, the different client routes being encapsulated by different IPsec SA attributes. Next page, please. This one is showing how use BGP to control the second scenario, which is to show that the client routes can be carried by either the IPsec tunnel or through the private VPN. So the CP itself has, in this example, has 4 different paths. Basically, like for example, VLAN 15, this route can be carried by the port towards the PE, which is carried by the VPN, or can be carried by the IPsec association associated with the port 192.0.0.1, or can be carried by the port 170.0.1, or can be carried by the loopback address. So using BGP, we can very easily to represent this property. So basically, you have the prefix 10.1, for example, and using tunnel encap to indicate that this particular route can be carried by one of the 4 tunnels. So this tunnel encap can be very easily be able to represent this property. And there are 2 other drafts to show that this can be IPsec attributes need to be added to the tunnel encap. Okay, next page, please. Oh, this one is about in the SD1 deployment.
Linda, can you wrap up, please, because you've got 1 minute to go.
Go to the next page, please. No, I don't have to talk about this page. Next one. So, Nick, can you give me another page? Just the previous one. Okay. So this page is not this one. Next one. Okay. So this page is. Oh, sorry.
Which one do you want? Give me a number. This one.
This
okay.
one. Yeah, this one. Yeah. So this is to show that. Oh, actually, this is This is PE-based SD-WAN. Okay, I don't have to talk about that. This is similar BGP explanation. Okay, so I'll just conclude my presentation then. I know that the working group adoption call has issued, and I think it is very important document for the other standard bodies to show how IETF has handled this SD-WAN and be able to use BGP to achieve the control plan for this overlay network. That's it. Thank you.
Thanks, Linda. Adrian, do you want to ask your question?
Yeah, listen, I won't use up time except to say that I'm bothered by the term application routing, and I'll write something about it on the mailing list.
Okay, thank you.
Thank you.
Thank you so much.
Okay. So next is Wenlin.
Hello, can you hear me?
Yeah.
Okay. So I'm just gonna present this draft MPLS NFRR. This has been presented last time in the intro meeting, in the MPLS intro meeting by Corrady. So today I'm gonna present it in the BESS working group. Next slide, please. So problem statement. FRR has is a very efficient way in protect link failure and achieve link node failure and achieve fast convergence. So it reduced packet loss, and this is well known. And usually it is a strong incentive to use MPLS as a data plan. It has been used in the RSVPT, LDP, Sprint, and also widely used in the MPLS-based service such as EVPN and IPVPN. But however, FR may cause packets loss in some circumstances. That's usually happen when FR is already happened and we encounter a second failure in the network, it triggers another FRR. So this can also happen in a single failure case in some situation. So when this happens, it causes problem and congestions to some links. This draft describes some of the situation and proposes a solution to using special purpose label. Next slide, please. So situation one, this is MPLS-based service. It could be EVPN or IPVPN. In the picture described here, we have C1 and C2 clients of EVPN or IPVPN, and C1 is dual homed to P1 and then P2 in all active fashions. So in a lightweight FRR case, when C2 send the traffic to C1 and the P3 forwarded to P1. P1 detect the link failure L1, and it in that case P1 will use a protection pass, which is pre-signaled and programmed in the PFE, and the P1 will send the packets to C through the protection pass via P2, and P2 will forward to C1. Similar things happen if the packets arrive on P2 for traffic go to C1, P2 will do the same. The protection pass for that L2 will be P1, and then P1 sent to C1. This is a very generic egress link protection in a lightweighted way, and for layer 3 VPN could be or EVPN. Next, please. So what happened is if C itself fail, and P1 sees the link failure and triggered egress link protection, the packet to C1 will send to the P2 a backup pass, and to via P2 and to C1. But since CE1 also suffered the node failure, most likely P2 will also see the failure on its local link L2. P2 will also trigger its FRR. In that case, the P2 will send a packet to P1 and again getting onto the P1. So it's trigger another FRR. So this is in this case, second FRR is not helpful. It causes congestion in the link L3. Next, please. So FRR can also use in the MPLS transport. In this case, this is a standard FRR for links. So using RSVPTE or XLFA, P2 will activate FRR if it detects the link between P2 to P3 fail. And on the same note, P5, if it does, it also detect the link fail of L2, it will also trigger FRR. If link L1 and L2 fails, both of them fails, so this causes fate sharing, and both P2 and P5 activate FRR, cause congestion in the link between them until LSP is rerouted. Next, please. So situation 3, and this is IMR node failure case. So in IMR, protection is done by two counter-rotating LSP, either clockwise or anti-clockwise to the egress node. Now say, for example, if a node 5 needs to send traffic to node 1, and it sends using the clockwise path. And but the link between 7 and node 7 and 8 fail, so node 7 will send the traffic anti-clockwise to node 1. That's in single link failure case. However, if node 1 itself suffers failure, in this case, node 0 will protect the traffic and send the traffic backwards, the anti-clockwise to node, trying to send to node 1. But when they get down to node 2 also detect the failure and trigger the FRR and protection by sending the traffic clockwise. So the traffic will loop forever. Some strategy has been proposed in the IMR draft, but it's not perfect. So next slide, please. So this is talking about what's the solution. So for situation without no further reroute, which is NFR. So as stated before, in this case, the label VL1 and VL2 are VPN label. VL1 is advertised by PE1, VL2 is advertised by PE2, and a TL represent the transport label. So when same scenario as talked before, when C2 send traffic to C1, P3, it goes through P3, and the P3 choose P1. So when the label stack will be TL1, transport label L1, and the VPN label L1. So when traffic arrive at P1, what P1 sees is a label VL1. The tunnel label will be popped or PHP applies, and P1 detect link failure to L1, it will trigger the FR, send the traffic to P2 instead. The label stack will be transport label 2 and VPN label 2. So when traffic arrive at P2, it sees the label VPN label L2, which is allocated by himself, and he also detect link L2 failure. It will trigger FRR. This is a loop, right? As I talked about before.
Okay,
Next.
you have 1 minute to go, so can you?
Okay, next slide. Yeah, okay. So the solution proposed to use NFRR. NFRR is a special label to indicate that FRR has already happened. So in this case, a similar case as before, when P1 triggered FRR, it will push NFRR label after VPN label. So P2 receive it. P2 will see when it popped the VPN label L2, it will see NFRR. The indication, NFRR indicate to P2 that this is traffic coming from a backup path through FRR. So in that case, when he sees the link down, he will no longer trigger another FRR. He will simply drop the packet and prevent the loop. Next slide, please.
Can you skip to the last slide, please, because we really are out of time on this one.
Yeah,
I think there's I think there's one comment from Hokke as well.
Yeah. So why label FR? So label FR is we want to provide a generic solution because this is a common problem, as I specify in a lot of cases it can happen. And so using a generic solution, and whenever in the forwarding plane it sees the NFR label, it will simply no longer do another FRR and stop in the loop. So only things we need to add is to signal the capabilities to support an FRR label. And we do not need a control plane extension to specify how to signal this label for prevent another FRR. So that's the reason to go with the special label. And we like to have a further discussion on this draft in the mailing list, and also have a companion document to signal the ability to process the NFRR. So, and examining of technique and algorithm to better understand and know what circumstances to use this special label. So that's all.
Okay.
Hi, can you hear me?
Yeah.
Hi, okay. Yep.
Hey, Wen. Yeah, a very quick one. So in these slides, you talk about EVPN and IPVPN, but in the draft document, I read in section 2.1 that you refer to a VPLS as well. Is that a mistake or is intentionally?
Yes, that's not a mistake. Yeah, VPLS too.
So so this can happen also with VPLS?
It's more like if a VPLS is trying to do, yeah, if a VPN only support active standby, you're right. I should clarify. So, because I was more talking about the situation for an all active due home. But in the case, I was thinking about another use case in active standby. This can also be used. I'll clarify that.
I see. Okay. And the other one is in the EVPN case, it would be nice to specify how the procedure works. When you receive from the remote PE, you receive traffic with the multicast label, a multicast VPN label. But the multi-home PEs, the traffic is known unicast, right? So all those details are important, I think.
Okay, thank you.
All right, thank you.
Ali, I think just if you can keep this brief.
Can you hear me?
Yeah.
I'm wondering that instead of using an explicit NFRR label, can PE2, given that PE2 advertise VPN label 2, it allocates it such that when it receives the label, it knows it is used for the FRR, and thus it doesn't send the packet again if it is locally attached AC. is failed. So do it basically do it implicitly as opposed to explicitly.
So if the same label is used, thank you, Ali, for the question, comment. So the thing is, if P1 send traffic, FR traffic to P2, use VPN label of P2. P2 has no way to distinguish whether this traffic is coming from remote PE or it's coming from P1. So because of that, P2 will trigger FRR. There's other way is you can allocate a separate label, you know, so we also thought about this, but the things for that, a separate label, in case it depends on label allocation scheme, right? It could be like a label per interface, label per bridge domain, like EVPN, or label per EVI. So it means a lot of label need to be allocated to distinguish traffic, whether it's coming from P1 or from P3, which is the remote one. So, and also you need to weigh to signaling, and EVPN, what does his own way, IPVPN, what does it his own way, so it's RSVP, you know, all that different protocol, what does it his own way. So like you have a control plan extension to do this. So since the problem is generics, that's why we propose to using a special purpose label to indicate no further FRR. Thank you.
Okay, can I ask that we take it to the list now and move on to Garen's presentation?
Hi, can you hear me?
No, we can't really hear you. It's very muffled.
Let me try that. Hello?
Hi, yeah, it's very, you got a lot of echo and it's very muffled still. Yeah, it's just not working at all. Nope.
Is that
Unfortunately not.
I turned the volume down a little bit and made it after the volume. How did you turn that down?
Karen, it sounds like there's a problem with on your end, I think, with your audio. I think we need to move on because we're going to run out of time and get cut off. So, okay, sorry about that. Ali, I think you're on next.
All right. Can you hear me?
Yeah, that's clear.
So given that Niraj is not here, I can cover his presentation as well. So I can go over this one, and then after that, we go over the unequal load balancing. Is that okay?
But probably at the end of the session, just to ensure we still have time for the last presentation.
Okay, sure. So I got a 10 minutes slide, 10 minutes time slot. We'll see how much I use. Maybe I can use it within my 10 minutes time slot. This is a short presentation. This is Rev 0 of the Secure EVPN draft. And the next slide, please. A little bit of the history. Rev 0 was published about 2 years ago and presented at the IETF108. Rev 01 was published in March of 2019 and presented at 104, IETF 104, and Rev 02 was published a few months after that in July of 2019. This is Rev 03, and Rev 03 relative to the Rev 02 is basically a refresh. Next slide. A little bit about the background and solution overview to just refresh people's memory. The secure EVPN, it sets up, the whole gist of it is setting up a point-to-point IPsec tunnels among endpoints using point-to-multipoint BGP signaling. To do that, we do a secure control channel between each PE and the ROS reflector, and that can be done using the existing IPv2 protocol to set up the point-to-point tunnel over which the BGP session can go. So BGP session goes over a secure point-to-point tunnel, and once we have that, then BGP signaling, we use BGP signaling point-to-multipoint to establish the point-to-point assays among the interested parties. And in doing that, we don't need to use point-to-point signaling, and as such, we reduce the number of the message exchanges from order N squared to order N. Next slide, please. When a PE first comes up and wants to set up an IPsec assay between itself and each of the interested remote PEs, it generates a Diffie-Hellman pair for each of its intended IPsec assay using the algorithm defined in IPv2 Diffie-Hellman group transform. The originating PE distributes this Diffie-Hellman public value along with the nonce using IPsec tunnel TLV in the tunnel encapsulation attribute to the other remote PEs via the ROS reflector. And each receiving PE uses this public Diffie-Hellman number and the corresponding nonce in creation of the IPsec assay pair to the originating PE. Next slide. So that's basically a gist of how this point-to-multipoint signaling is used to set up the point-to-point IPsec tunnel. So the changes in Rev 01, we added the requirement for setting up an IPsec assays between ingress, the requirement for setting up an IPsec tunnel between a pair of ASs between ingress and egress PE. We added new section on inheritance of security policy, and we modified relative to the Rev 0 the IPsec tunnel attribute sub-TLV for better optimization. And in Rev 02, we added sections on zero-touch bring-up, configuration management, orchestration, and signaling. And Rev 03, which is this one, is basically a refresh. So next slide. One of the things that the draft covers is basically a method of the inheritance, and for the granularity of the IPsec tunnel. So the IPsec tunnel can be set up at a very fine grain of granularity on a per MAC address or per host IP address, or it can be set up at a coarser granularity of subnet or per tenant or even per PE. And once you you set it up on a per tenant or subnet basis, you send the IMET route with this tunnel attribute. If the MAC addresses that are associated with that, or IP addresses that are associated with that subnet, they don't explicitly carry the tunnel attribute. It inherits that from the its parent or hierarchical route. This is one way of inheritance, and there are two other scheme of inheritance exists. One based on the recursive route resolution, and the second one based on coloring, and those two are being described in the tunneling cap route. So next slide. The draft has been around for a couple of years, and it's been stable for over a year. So it is, we think, the authors think that it is ready for a working group adoption call. So we like to be, the draft to be put in the queue for the working group adoption call.
Okay, thank you. Sue, I think you're first in the queue. Are you deliberately trying to share your screen, or?
Me? No, I'm not trying to share my screen. I turned my video off.
Okay,
so
it's all right. Never mind.
I can't. I turned it off so I wouldn't be able to from permissions. So
Yeah.
not
Okay.
trying to. Okay. Ali, there. I find a few things that you stated in your slides. If you can go back 2 slides, I can be much briefer. We went through this at IETF 105 to try to work on the security issues. Thank you for participating in that. The thing that you've stated here in the slide that you have a IPsec tunnel, that's not what you have in the draft. What you have in the draft is a definition of two new tunnel types. Could you explain the difference between your slides and your draft?
So the encapsulation is IPsec tunnel, and then you can use the IPsec tunnel over UDP, and because we got the VXLAN encapsulation, okay, it describes how we can do IPsec encapsulation that covers VXLAN, and those formats being described in the draft, because this is not your regular IPsec, but it carries the VXLAN encap.
Okay, so the natural tunnel encaps draft has VX tunnel encapsulation in -17, and I wondered why you didn't use it. And I'm going to be really brief and just point things that I don't understand. The second is you actually define a new tunnel type, and you seem to be doing the same sort of things that are in the IETF. I wanted to know in the draft why it's different, why you needed the new tunnel type, how that interacts. Can we have commonality with the new IPs, with common IPsec stuff that's there? So I don't find the draft to be ready for an adoption call unless the working group feels there's a lot of work yet to be due. I just don't understand some of the pieces.
Okay, so if some of the pieces is not clear, if you can send it on the mailing list, and I'll be more than happy to reply to it. And for a clarification question, it can be as simple as a clarification question, and I don't want to hold the draft for a clarification question.
I don't think it's a clarification. I think
Obviously,
as a
and as I said, that's just you know, we looked at it, and in terms of the available tunnel type and the encapsulation, and I'll be more than happy to
why don't you just answer on the mail list the question I asked you, which is why are you picking up a new tunnel type instead of using
so can you please send me exactly, you know, the references that you made, that it is, you said there is already a tunnel type exists that can handle, you know, that we can cover, we expand with the IPsec. Can you send the reference for that?
Sure. I'll be glad to exchange this on email, but you know, you've put in your slides that you have an IPsec tunnel type and you're defining a new one. I just wanted to know which one. Thank you very much.
Thanks,
okay.
Lou. Linda, you're next. Oh, it's hang on. You've gone very quiet again.
Oh. Okay. So my question is, you have a TSP transport.
Linda, you're still, to me, you're still inaudible.
Can you hear me?
That's better.
Yes, better.
Okay. So in the draft, you have two tunnel types. One is the ESP transport. Another one is ESP in UDP transport. I'm just curious, what's the difference in those two? I read through your draft, I couldn't understand.
So one of them is it is intended to be used for the NAT, and the other one is not. And the encapsulation, if it is, I thought the description for the encapsulation is clear, but if it is not, I'll be more than happy to expand on that.
Okay, thank you.
Thanks. Okay. Okay. Just make this really brief, please.
Hi, Ali. A quick one. I saw in the IANA section that you guys are requesting a new VPN extended community. Sorry if I missed it, but how is that used?
I'm sorry, I couldn't hear you, Jorge.
I'm sorry. Can you hear me now?
A little bit better. Yes, go ahead.
Yeah, I was saying that in the IANA section, there is a request for a new EVPN extended community. But I couldn't find in the draft a description about how to do it.
That might be a mistake.
Okay, so it's a leftover from a previous version?
Yes.
All right.
Thanks for bringing that to my attention.
Yeah, sure. Thanks.
Okay. All right, thanks. Fine. So we have Christian next. You're on.
Hi. Hello, everybody. This is Christian from Cisco. I would like to introduce you to the concept private line emulation. We have published 2 new drafts that you can see here. And I'm speaking as a representative of the folks that here are on the list of authors. We have been working on this concept for quite a while with a group of service providers, and actually Verizon co-authoring the draft with us has been on the forefront defining this technology. If you can go to the next slide. Thank you. So there are 2 drafts. The first draft is defining the data plane. Essentially, it's defining an encapsulation mechanism for bit streams into a packet switch network stream. You may wonder, why am I deciding this now? Because we have actually 10 to 15 years ago in the PWE3 group already defined things like structure agnostic transfer over packet, like RFC 4453 and others. But back then it was a focus on low speed signals like DS1s and E1s or frame relay. And now we're trying to tackle the problem: how can you be transparent carry high speed signals such as 10 GiG, 100 GiG, or even 400 GiG in the future. And I will touch base on why somebody would want to do that in the next slide. But also important is that essentially we are trying this time also to define the encapsulation to be underlay agnostic, so it shall apply to MPLS as well as SRv6 networks. The second draft is addressing the signaling aspects of private line emulation. Essentially, we are proposing a new PLE path attribute for BGP so that we can use the EVPN VPW signaling that already exists to signal those special VPWS types. You can go to the next slide, please. Can we go to the next? Yeah, thanks. So let me spend 1 minute to clarify why am I actually proposing, or why are we proposing this, and why I'm explaining that there is a need for bit transparent transport over MPLS or SRv6, as now actually everything has moved to IP. We shall not forget that today in the carrier space, there are still a lot of services which are circuit oriented, where somebody wants a point-to-point connection, potentially 100 GiG between two data centers, and there needs to be guaranteed bandwidth, more or less like a time slot. People are asking for a dedicated wavelength, for example, right? You know, a connectionless packet service would not satisfy these requirements. And people are using either direct wavelengths or optical transport networking switching technology to accomplish those kind of services. But what we have seen is, with the explosive growth in packet switching silicon capacity, it is now no longer cost effective to actually carry these kind of services over OTN, but rather actually the cheapest way to carry this kind of traffic, even if you don't oversubscribe and pre-allocate the bandwidth, is actually deploying an MPLS or packet switch network. This also gets amplified by innovation in optics, where now you can actually implement DWDM optics inside the routers, which makes the network even more. Slide. Hello?
Hi, your audio keeps flipping. I don't know if it's dropping. I don't know if it's just me.
Okay. Yeah, I'm hearing an echo now.
It's not just me. It's yeah. Go ahead anyway. See how it goes. No,
okay, can.
Oh no, you disappeared. Okay. Can you try speaking?
Hello, can you hear me?
Yes.
Oh, sorry, I did go back out and in again to stop the echo.
Okay. Okay,
so essentially with this now, you know, what I meant to say is people can now build an MPLS network rather than building an MPLS network over an OTN network. Now, what do the drafts actually propose? The first draft proposes an encapsulation for those bit streams using somewhat, you know, a known reference model where basically a VPWS instance is established between two Ps, in my example here, PE1 and PE2. And you can use it, you can use any underlay underneath, being it an MPLS you know, tunnel or an SRv6 data plane, whatever you have. The interworking function is responsible to take the bit streams and encapsulate that into packets. And we are proposing two payload types. One is a constant bitrate payload type, where basically just a bunch of bits without any care of structure are getting received and encapsulated in a packet, and the packet is getting sent across. We're also proposing a frame-aligned payload, which is specific to cases where the attachment interface would be an OTN interface. We are leveraging on well-known mechanisms like using a control word to support sequencing, as well as have the ability to have data plane failure indication, being it client layer forward indication with the LBIT or server layer, in order to make sure that the stream is properly sent.
Your audio is dropping again.
Okay, sorry. Is it better?
Yep.
Okay. Last but not least, we are applying differential clock recovery to make sure that the bit stream has the proper clock on the far end. For those of you that might have looked at PWA3 stuff from the past, we are trying to align with previously well-accepted technologies, and we're basically just adopting it for different and new types of clients. Can we go to the next slide?
Sorry about that.
No worries.
Fractionally challenged. There we go.
Thanks. From a signaling perspective, we are leveraging the EVPN VPW's mechanisms that already have been defined. Really, the only new thing is, because EVPN really is centered around Ethernet, as the name already indicates, we now need a new BGP path attribute to indicate the non-Ethernet aspects of attachment circuits. Things like what's the bit rate of the bit stream, right? What is the payload size? For this technology, it is important that both endpoints are using the same payload size, for example, otherwise the transport would not work. We also have added a section for LDP, but at the stage of the revision of the draft, the LDP extensions are preferred to start. And I think this comes to the last slide. So this is a very quick introduction to the concept and the two drafts. Thanks for having me here. I didn't go into a lot of details because we only have 10 minutes. We already had some questions on the mailing list, and we would appreciate your feedback and your input.
Okay, any comments or questions? Okay, sorry.
Yeah, can you hear me?
Yes.
Yeah, so the first draft talks about an encapsulation. So why is this draft in BESS? I mean, there is no BGP-enabled services in there, right? It's just describing the encapsulation.
Yeah, this is a very good question, and apologize. I'm also an IETF newbie from a contribution standpoint. We got the feedback that potentially this draft should be better positioned in PALS. I think this is from under consideration. We don't really have any religion on what working group that belongs, and I think.
Yeah, for the moment, Jorge, it's just an individual draft, so it doesn't belong to any working group yet.
Okay.
Yeah, but
thank you.
I think the question is, I think the chairs need to discuss with the PALS chairs, because obviously it's a case of where the expertise of the encapsulations resides, and because all the emulation over encapsulations for emulating TDM and SDH services and so on was done in PW3, which kind of became PALS, and that's really agnostic of the control plane in many respects. So I think that I was just quickly checking the charters, and I think PALS is probably still sort of chartered to, even if it's just an encapsulation, to do that. So anyway, we should sync up with Stuart and Andy.
Yeah, and even the second draft, there is a ongoing section about LDP that should also go to PALS somehow.
Okay. Any other Any other comments? Okay, thanks. We have 5 minutes, I think, left. Ali, I think you were going to quickly go through the one that Niraj was not available for, the unequal load balancing. Correct?
I can cover that quickly.
I'll try and find this one. Yeah, just go through it as quickly as you can.
Okay, sure.
That'd be great.
So this is only fewer slides. Next slide, please. Just a quick recap. The draft is about the unequal PECE link bandwidth distribution within a multi-home Ethernet segment. And that itself consists of 2 things. One is procedure for unequal load balancing of flows from the remote PEs. And then the other one is procedure for unequal load sharing of DF rows across PEs in that Ethernet segment. Both overlay unicast and bump flows load balancing needs to be done in proportion to these access link bandwidth share in the lag. Next slide. So the status of this working group last call got initiated in the March 2020, and the comments were addressed in the latest revision, except one outstanding issue, and that outstanding issue is link bandwidth extended community, which is referenced in draft IETF IDR link bandwidth. Next slide. The issue that we run into with using that extended community is it is being defined as non-transitive, and EVPN needs it to be transitive. And because of the existing implementation and deployment of the existing extended community, link bandwidth extended community, it is difficult to try to use that in a transitive mode. So the proposal is a simple proposal. It just define a new link bandwidth extended community for EVPN that is transitive, and the type is 06 EVPN, and the subtype is the next available subtype, which is currently 10. So that's it. Next slide. That's it. So that was the quick overview of the only outstanding issues that we need to address.
Hello.
And that has currently been already added to the latest rev of this draft, and it got published a couple of days ago.
Thanks. John, I think you were first in the queue.
Hey there, John Scudder. So, Ali, if I understand you correctly, with the proposed transitive version, it would sometimes be transitive and sometimes be not, depending on whether you're doing next hop rewriting. So there has to be a logic on the border router that decides whether to transit the thing or not. Is that correct?
Correct.
So in that case, I would say that you can do that just as well with the non-transitive community, because what you're really doing on the border router is you're originating a new community based on the condition that you've defined. The new community you're originating happens to have exactly the same set of bits in it as the old community you terminated, but that's, beside the point. I don't think you're violating anything if you're conditioning it on the next hop.
Very good. We actually, John, considered that, and we ran into issues that the existing deployments, the existing deployment that use these existing EC, they basically behave certain way, and we cannot update the changes that how they're gonna behave and so forth for these for the existing extended community. But for the new extended community, you're at the position that we can define the behavior, including the conditional transitivity. Because of that, as I said, we started by using the existing one, but we ran into issue with the existing deployment.
Okay, not completely clear to me, but in interest of time, maybe can I ask you or your co-authors to write up the problems that you saw in a little more detail?
Sure.
Okay.
Yes, please take the discussion to the list.
With respect to the existing EC and the deployment issue that we saw with the existing deployment.
Thanks.
Okay,
sure.
Thank you.
Yeah, we just have 4 minutes before being kicked out.
So, Jeff Chancellor.
Hi, can you hear me?
Yes.
Yeah, so the problem with the community, it's been abused or used incorrectly, intransitive way in eBGP deployments as well, especially in data centers. I tried to contact authors probably 3-4 times on LinkedIn, didn't really work, so I suppose we should really redefine the community as transitive and be done.
Okay.
Very good.
Thank you. Jeffrey, maybe just one quick comment from you. You were in the queue. Jeff House. Are you there?
I am showing microphone, but I'm not hearing anybody responding to me.
Oh, well, we can hear you.
Thank you for the confirmation. Very quick comment. Employer Juniper, work on Juniper's BGP implementation. We've been using the transitive version of the link bandwidth code point for our entire time. We actually don't support the non-transitive one. My suggestion is, we have a code point that works. The primary issue that we have, and we've had this discussion, is we've been recently asked to support the non-transitive version, is how you actually make the two code points comparable. So I think that's actually the way we probably should want to take this forward.
I'm sorry, what was the last sentence?
The problem is, how do you actually take both a transitive and a non-transitive link bandwidth, which are different code points technically. Really, they're just something with a different bit flipped. And how do you make them comparable to each other? So if you have implementation that receives a transitive from one route, non-transitive from another route, how do you make sure that you compare the two for load balancing purposes? How do you make sure that load balancing happens appropriately as they cross the boundaries? Those sorts of things. And that was going to be an issue with your proposal no matter what. You have to figure out the comparability of these things based on effectively the scoping.
With respect to your earlier comment that you've implemented the transitive, so the EC is being defined as non-transitive, and as far as I know, all other vendors have implemented the non-transitive version as specified in the draft itself.
I make no claims that Juniper did the appropriate thing at the time. It was well before my time.
Okay, so that's the thing. Now the question is, with the many vendors have implemented non-transitive based on what the draft has specified, then try to force that into becoming a transitive, then which is already the encoding in the EC indicates non-transitive. That can cause issues with the existing deployment. But
I will follow up to the mailing list.
Yeah.
Okay, folks. I think we're out of time. My clock is saying we have less than a minute to go before we get the boot. So thanks very much, everyone. I'm going to put it off there. and see you next time. Thank
All
you.
right, thank you.
Thanks.